I'm going to be giving a little bit of a demonstration of the so-called chaining activity for SER 222 or CST 230, the Data Structures and Algorithms course. The assignment is given to you as a set of files. One is called chaining.java. And in addition, I have some files like test1.in, test2.in, and the expected output, test1.expected. So if we look at those really quickly, test1.in is a list of words, and sometimes it just has the word, and sometimes it has that word with an equal sign, like anti-egotism equals electrometric. And when you run the program, the result should be whatever is in the expected file. So if I look at test1.expected, then I can see how the hash table works. If I scroll up, the first thing in the input was the word anti-egotism, so it looks it up and it doesn't find it, so it returns null. When it said anti-egotism equals electromagnetic, it inserts this into the hash table and then prints all of this information. Sorry, there's a dust storm. Prints all of this. We're in Arizona, those happen. It prints all of this information about the hash table. So you can see how it should work entirely for that. Now, if you're in Linux, then you can run the program directing the input in and compare the output to what was expected. So let me clear the screen. The first thing I would do is compile my Java source code, and if it's all good, I should get no warnings or errors. And of course, now I have a series of class files because that Java file contained a class called chaining.hashtable and chaining.node, so they each produce their own class files. And in order to run that, I just type Java chaining, and I have now an interactive session. I can type in key equals value to insert a key, or I can just type in the key to look it up, and Control D when I'm done. So I could say, happy equals today, and it inserts the association. Happy gets associated with the string today into the hash table, and then it shows me the hash table. The size of my hash table is 1. There's one thing in the hash table. It currently has a capacity of 10. I've got 10 bins, and the load factor is 1/10. So I can see here in bin 4 it inserted happy and today. So this is the first node in bin 4. All right, and I can do another one. I could say sad equals yesterday, and I misspelled it, but it's fine. So it inserts the key sad associated with the word yesterday, and my hash table size is now 2. I verify it should be. Capacity hasn't changed, but the load factor is now 2/10, and I can see that happened to go to bin 0. And I can do a couple of more things. I could do A equals B, B equals C, C equals D, D equals E. The nice thing about letters is they're naturally going to hash to subsequent bins. E equals F, and then G equals, so this is going to be a collision because this is going to go to bin 0. G equals H. Now the load factor went above 0.7, and the way that I have this hash table set up is when the load factor goes above 0.7, it automatically resizes the hash table, and therefore we didn't actually get a collision. Instead, it resized the hash table, and you'll notice that all of the keys are in different locations. Like bin 0 is no longer the mapping of sad to yesterday. That's instead at bin 10. Right? If I want a collision, I could do apple equals orange. That'll probably be a collision. Nope. Let's just keep going until we can maybe get a collision if we're lucky. There we go. We got a collision because I inserted the mapping key Z to value Y, and that went to bin 10, but bin 10 already had sad associated with yesterday. Now that bin contains two items. The first thing is Z is associated with Y, followed by sad is associated with yesterday. This is what chaining is all about, so it chains them together. So we can see here the capacity is 20, the load factor is 0.5, which is the way that it should be. So this program lets you visualize what happens to the hash table and all of the bins as you insert keys. You can also look things up. If I just type in Z and hit enter, it'll look up Z and it'll find that Z was in fact associated with Y. I can look up sad. It'll look up sad and say that sad was associated with yesterday. If I tried to change a mapping, so right now if I look up A is associated with B. If I say A equals C, then it tells me that it inserted the mapping A goes to C, and it returned the previous value of B, because up here I can see that A was associated with B, and after I associated with C, I can see here now that A is associated with C, and it just gives me access to the old value in case I want to do something with that. You'll find it's a very useful thing. So I think that kind of summarizes that. When I'm done, I press Control D and the program ends. So the program is over now, and I'm back at my command prompt. All right. I'm going to go ahead and clear the window. So again, Java chaining is how you run the program. Now if I want to run the program using all of the commands that were in test1.in, my input program, I can use this less than sign, the angle brace, to redirect test1.in as if it was the standard input. And here you can see it's run the entire program using test1.in. And so if you run the whole program, you can just kind of look at the end and see that it should be like this. Right? What you can also do is you can, let me go ahead and clear the screen first. So you can run the program and redirect that test1.input file as if it was a standard input, and with that greater than sign, you can direct the output to a file called test1.out to hold the output. Then when you run this, you won't see any output, but when you do a list, you're going to see that there's now a file called test1.out, and we can kind of look at that. I'm on an OS X machine, which is sort of Linux based, and if I type in head test1.out, it just shows me, the first part of the file, so I don't have to look at it all. Or I could type in tail test1.out, and I can see the end of the file. Right? So it's looking good. And finally, on a Linux system, I can type in compare cmp test1.in to test1.out, and it tells me that in fact they're different. So that's meaningless. Don't do that. I want to compare test1.out. Of course the input doesn't match the output, right? I want to compare test1.out to test1.expected. So I'm giving you the expected output for test1, and it provides me with no output, which means that they're exactly the same. Again, if I look at tail test1.expected, and if I look at tail test1.out, they're the same, right? So that means that my program works correctly. Of course it does, because this is my solution. I'm in the folder containing my solution to the assignment. If I were to, for instance, change directories into the assignment as I've given it to you without the solution, and I were to compile chaining here, I need to type in chaining.java. There we go. So I've compiled it, and now if I type in Java chaining, if I were to type in A equals B, you'll notice that it does nothing. In fact, the assignment that I gave you produces the output, but it doesn't actually build the hash table. So this is going to fail when I run it. So if I were to do exactly what I did before, I'm going back up. There we go. I'm running chaining in this new folder. So I'm in the exercises chaining folder, not the solution, but the actual assignment where you guys haven't fixed it yet. If I give it the input and I try to collect the output, and now I compare test1.out to test1.expected, it tells me that in fact they differ on line 12. If I'm on a Linux system, I can use Vim and look at test1.expected. Or actually, I'd rather look at test1.out, which was my output. Go to line 12, and I can see that, yes, indeed, they're different because I expect this to be a 1, not a 0, because I've just supposedly inserted the mapping between anti-egotism. So anti-egotism should have been associated with electromagnetic, but it didn't show up anywhere in my hash table because I haven't done it. Now, if you are using a Linux type of system or an OS X type of system with Vim, you can type in vimdiff test1.in or test1.out to test1.expected in order to compare these interactively, and you can go through line by line and it shows you exactly where they're different. If you can make sense of the color scheme, you can see here I've got a 0, and over here I've got a 1. Similarly, for the load factor on this, it's 0.0, but in the expected it's 0.1, and of course down here it's missing anti-egotism to electrometric. So vimdiff kind of gives you a visualization of how your output is different from the expected output. So in Vim, of course, you type in Control-Q to quit, and you're going to have to do it twice because it opened 2 files. I hope that is helpful. You may not have Vim or vimdiff, but you kind of get the idea of what's in test1.in and the other test and the outs, what the program should do, and good luck making this program work.